Hello and welcome to the second iteration of Sudoku Solver by Peter Norvig. Uh, in the last video we saw how a grid is going to be represented programmatically in Python, and now we move to how actually input is given to this program and how is it going to parse the input and check whether it's a valid grid or a valid Sudoku puzzle or not. So let's do a quick recap. Um, so these things are rows and these things are columns. Rows are labeled with A through I, and rows are labeled A through I, and columns are labeled from 1 to 9. Similarly, when we talk about some nomenclature here, there's something called as a unit. So you might ask me, what's a unit? So unit is, it might be a row, it might be a column, or it might be this small 3 by 3 grid that's in this huge 9 by 9 grid, right? So that's the unit. And there is also the term called peer. A peer is a term that is in the vicinity of a given term. Say let's consider 4, then all the terms in this row and all the terms in this column and all the terms in this grid become these peers, but there might be repetition. So in order to avoid that, we take a set and we take a set difference of that to get the absolute set, plus we subtract the element itself from that because it can't be a peer for itself, right? So that's the nomenclature ahead. And now let's see how this input is going to be parsed, right? So check this out. The input might be given in one of three ways. One way being the numbers in the grid positions followed by dots, right? So this will go on horizontally till a particular limit, then break there, then it will start filling again vertically from the next row onwards. So if it were 4 dot 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 something 8 5 3, so till 5 it's 9 numbers. So after till 5 it's 9 numbers, so it's going to fill till 5 and then again go back to dot 3 and so on and so forth. So that's one way of doing things. Otherwise the input would look like something. Instead of dots it would be zeros and it would be given in the matrix form. It looks like certainly looks like a matrix form. Otherwise it will be plain old Sudoku grid type input. So we have currently we have three inputs at our hand that we are supposed to be parsing and checking for perform input validation on this. So let's get to the programming part of this. So parse grid. So what are you doing in parse grid? First of all, we look at this function, then we'll come back to this. So for C in grid, if C in digits or C in 0 dot. So what this statement would do is this would convert all of the input characters that are given into a single array, a single list if you will, because this is Python. So single list, how will it do it? So you might recall that we have a variable called digits and it's a string from 1 to 9. So if an input character, when it goes from left to right or top to bottom and it faces a character, if it's a digit or a 0 or a dot, right? 0 or dot, it's mentioned 0 or dot here. So sorry, if it's a digit or a 0 or a dot, it's pushed into the array. If it's 0 or a dot, it's quietly ignored, but if it's some other character, it's taken care of and that character is not pushed into the array. And we will see how this is going to affect how we tackle the input faulty inputs when it comes to that, right? So and here see, assert length of cars equal to 81. So we have pushed everything into an array, and by now we should have an 81 array we should have a list that's of size 81. Why do we ask it's 81? Because there are 81 characters. There might be some dots, there might be some empty spaces or zeros together, but all in all we should have 81 elements. If we have less than that, or if we have more than that, then something is seriously wrong with the input. So if it's not that case, then we'll build a dictionary and we'll zip the squares and chars together to return a dictionary. You might ask, what squares? Squares is the list that contains elements from A1 through I9. So this is going, zip method is going to combine these two less into a key value pair that's given to a dictionary that's of the type dictionary. So A1, so let's consider this input, right? So A1 would be 4. So squares of 0 would be A1, and chars of 0 is 4. So that's pushed into a dictionary, right? And so on and so forth. If this is a 0 or a dot, same thing happens for that, right? And now that's just input validation. Now let's parse this grid. So so every grid has to be proper for this code to work. So we start from 0 0 grid and check for the integrity of the grid. If something fails and if we are not able to assign the values to a grid, then we return false, else we return the values. What values? Again, it's this whole Sudoku grid that we are talking about, and there is a function called assign here, and there's called function called empty here. We'll talk about that in just a minute. Right? So yeah, let's come to the assign method. So what does assign do? As the function aptly suggests, eliminate all other values except d from the values array and propagate return values and return false if a contradiction is detected. So what that does mean? It means that it takes the value array and it replaces d, that's the number that you are given, with a blank space that is to set the grid in order to get it solved. And it also checks with the peers, meaning the row and the column and the grid. If something is if something is found to be contradictory when it comes to this grid, it might be row, column, or the small grid, it will always return false. Else it will check everything and it will return values, meaning that our grid is now constructed. So we have a string here that's filled with zeros. That's the second way of giving inputs. So when we call display of parse underscore grid 1, internally all this functionality is called, and then this grid of Sudoku numbers is actually generated for us to see. So that's about it. Thank you.